Thank you. And there we got the screen. So this was actually my office for a couple of days in February, but more on that later. First, thanks for inviting me, and I will try to guide you a little bit through what we think about 60, what that is, and with a little bit of connection to AI as well, so that I can stay on this panel. First, to put things into perspective, in the telco business, we're keen on talking about Gs, and they come at a regular cadence every 10th year or so. So what we have out in the field now that is about to be deployed or coming out is 5G. And since I'm a research guy, I'm 10 years ahead, so I'm more into 60. And when I say that, I mean 2030 and beyond. But I think this slide, you can say a lot of things about it. But one thing is actually that the big change here, I would say, is between 4G and 5G. Maybe not so much because of all the technical solutions, but because we go beyond the smartphone. 5G really tries to address more use cases, go into factories, help production, help society and things like that, compared to the previous generation, which have been very smartphone-centric or phone-centric, if you go even further back. So that's one big change. I think the type of problems we address is vastly different in 5G. Of course, we still do the smartphones as well. I think you can also use this slide to connect a little bit to the first panel. What we've seen of the Gs, if you start with 1G, that was very much about regional standards, maybe even country-specific standards, moving into one global standard in 4G and 5G, which was great. Gave a big market, big volumes, low cost and everything. So the question is now, what will happen with 60, given the geopolitical situation? Will we diverge again, or will we stay in one global standard? And I really hope that we will have a global standard, and I think most companies are on that track. Moving on to 6G. I won't talk about all the bubbles here. We can definitely dig deep into technology if we're keen on that, but I won't do it on stage. Main message here is really that 60, we try to connect physical reality with a digital reality. So you can have a digital twin or whatever and go between them. And you can do things like digital twins, Internet of Senses would be remote sensing. In some sense, that is what we've done from the beginning. It started with voice. You can talk to people far away. Then we added videos, so you can see people far away. Why should we stop there? Why not continue and basically bring all the senses remotely? We will connect machines. That's building on the 5G story. We have to connect the sustainable world here, which is basically twofold. It's both reducing the energy consumption in the networks, connects back to the previous panel, and also help the society to become more energy efficient. Maybe by doing more remote meetings, controlling houses, whatnot. I mean, the jury's out there. You basically have starting that journey in 5G and continue with 6G. But the main point on this slide is really about the pillars at the bottom. Past Gs has been very communication-centric. So that's basically just been the blue one, and of course we have the security and things like that. But with 60, we really try to address something broader. Connectivity is still important, definitely. But also trustworthiness in a wide sense. That you should trust your system, that you should always be there, you shouldn't fail, your data should stay safe, etc. That's becoming more and more important. We have cognitive networks, and that is really about using AI to run the networks. Back in the old days, you had a lot of manual tuning on networks, set a lot of parameters. Now, we already now use AI in the networks to predict things. Should we turn on the base station or not, in order to save energy, for example? And you can actually, by using AI, save around 20% energy because you can turn on and off things in a smarter way. What we really would like to see here in the end is some form of intent-based management, so that I can tell the network as an operator that, please, I would like to provide a good machine-type service in the city, everywhere, with this and this date rate, etc. Go ahead and arrange it for me. And the system figures out by itself how to set all the parameters, fine-tunes, and updates as we go. We're not there yet, but we go in that direction. And we also see compute being a part of this big picture. So 6G is something much broader than just communication. So coming back to my February office, Mobile World Congress is a big event in the cellular business in Barcelona every year. Everyone is there, so Ericsson as well. We showcase products and everything, but we also did give 4 glimpses into the future at MWC this year. So we talked about the digital twin of a network, we talked about some new spectrum, we talked about really super high data rates, and we talked about zero energy devices. And that is what I will spend the rest of the time on. So what is a zero energy device? It's really a sensor without a battery from an end user perspective. And there's a lot of sensors out there. There's a lot of things you may want to sense. And this is one example with a collaboration we had with MIT in Boston, Massachusetts, in the US. They have created fabric with built-in sensors. By using a standard knitting machine, you can basically put in fibers in the cloth. And whenever 2 of these special fibers cross, you get a pressure sensor. It's not super accurate, but you get hundreds of them in your clothing. And you get normal fabric out of that. And here they built socks out of it. And by just sensing what you do with your feet, you can figure out what the person is doing by using an AI model fed with that sensor data from the feet. It's pretty fun. And the guy looks a little bit funny as well, but it's another story. So this is one thing you can use it for. And imagine that you play golf, for example. You want to practice your golf swing. You want to check out things. Maybe you can put on these type of socks. Or if you're a soccer player, you want to do something there. Or gaming industry, you want to run around shoot your friends in the woods. Not for real, of course, but as a game. So there's a lot of things you can do with these sensors. They also made a sweater out of this, that red sweater, connected to an AI model. And by reading these hundreds of sensors in the sweater, you can predict whether she is sitting in the sofa, laying down in the sofa, leaning against the wall, or whatever she's doing. Again, you can think of a lot of different use cases here. Gaming is one thing. You can think about healthcare. If you have elderly people that are not supposed to sleep in the same position all the time, maybe they can have this type of sweater on them, and you set off an alarm if they haven't moved for a while, things like that. There was actually even a guy at the Mobile World Congress that came to me and said, policemen should have this. When there's a riot, we can see if they've fallen down or not. So it triggered a lot of imagination among people what can you use these type of sensors for. Okay, is Ericsson going into the clothing business? No, that's not the intention. But if you look really carefully here, these sweaters here were connected with a cable. Because MIT did this in order they wanted to do research on body movement. So where we come in is really to connect them wirelessly. So I have another model of the sweater here. And you probably don't see it from there, but you can take a look afterwards. I'll be around. Where we have a small circuit here that we developed. It's about a square millimeter or so. And that little radio transmitter collects sensor information from the sweater, hundreds of sensors, transmit it to the receiver, and there's no battery. Because what we do, we harvest energy from the surroundings to power this device. And you can harvest energy from a lot of things. If you move around, of course, that movement is energy. If you have a cup of coffee, that's energy as well. It's hot inside, cold outside. In this case, we actually harvested radio energy, which is really, really difficult because the amount of radio energy around is very, very small. But you can do it. So you can sit here, there's energy in the air, harvest that for a couple of minutes, and then you have energy enough to transmit for a couple of milliseconds or so, which is enough for many of these sensing applications. You're not sending super high data rates, high resolution images. It could be that you want to monitor temperature or the sweat or whatever. So there's a lot of places where you really would like to have a lot of very, very simple low-cost sensors. Could be agriculture industry. You can place it in the crops to check out the humidity or temperature so that the tomato plants, whatever it is, grows in the proper way. Could be medical application. Just stitch it on your skin if you want to check your blood sugar or something. Could be a traffic monitor in a city. We want to see how things move around there, to see if there's congestion and see if we can do things. That will, of course, help to build a more sustainable society as well, if you can resolve these type of traffic jams or whatever it could be. So there's a lot of places where you need a huge number of sensors that should be simple and low cost. And you can take that massive amount of sensor data and feed into an AI model to get knowledge out of that. And in this sweater example, I mean, there were hundreds of sensors. They're not that accurate. But it doesn't matter because there's so many of them, and together they give a picture of what's going on. It can be the same thing in the city. Maybe not every sensor is super accurate. Doesn't matter because there's so many of them. So this is also part of 6G. Or maybe I should say it's even part of 5G because the journey is starting now. We see more and more applications beyond traditional smartphones already in 5G, and that journey will continue onwards with 6G. So with that, I save 4 minutes and end with my nice February office again. It was really intense days with thousands of people coming by and looking at all this research stuff that we showed up, but it was really fun to meet a lot of people as well. So thank you for listening, and I will have this up.
Thank you, Dr. Parkvall. This was truly astonishing. Myriads of microscopic sensors around us that do not need a battery, garments that understand and accurately predict our movement in space. I wonder, will they also read our thoughts?